Okay, example 2. This kind of goes back to some of the stuff we did in 2.1 where we picked really close to 1 if we were trying to figure out stuff about 1. All right, so they want us to evaluate f of t equals the cube root of t minus 1 over the square root of t minus 1. I took the liberty of already entering this in my calculator. A couple of things to consider when you're entering this. The top is a binomial, so in parentheses. The bottom is a binomial in parentheses. When you're entering the cube root, which is found at the math button, it's number 4, cube root. All right, when you're in the cube root, the bar keeps extending, and as long as the bar is extending, it's going to continue to go underneath the square of the cube root. You have to hit to the right when you were done to get out of there. All right, and the same thing here for the square root of x. When you're inside the square root symbol, oops, it's going to continue that bar until you push to the right to get out of the square root to finish out the thing. So just make sure that you're careful. The old calculators had a beginning parentheses and end of parentheses. These newer calculators, it just extends that bar till you push to the right to get out of it. I'm going to go to my table, and what we want to do is I want to figure out what this should equal at 1. All right? So, and it says to guess the value of the limit, but it doesn't ask me what the limit question should be. This limit as x approaches 1, or t approaches 1 actually, of the cube root of t minus 1 over the square root of t minus 1. All right, that's what it's asking us to do. All right, I can't put 1 into that. If I could, that's how you do a limit. Okay, if you can put the number in and it works out, you're done. I'll give you an example real quick. If I had the limit of 3x as x approaches 3, the answer is 9. Because 3 times 3 is 9. Easy, all right? But most of the time that doesn't work. So they want the limit as t approaches 1. If I try putting 1 in, and I just type it right in my calculator, it says error. Can't do it. All right? Not possible. So it's no good to do it that way. So what I need to do then is I need to get myself really close to 1 and see what's happening and make some guesses based on that information. So I'm going to start with 1.5, which is nowhere close to 1. It seems like it, but it really isn't. Then 1.2 is closer. 1.1, now we're getting to a decent closeness. 1.01 is 10 times closer. 1.001 is 100 times closer. And you can see the results here, 0.64, 65, 66, 66, 66. It keeps on, it seems to be flattening out there at the 0.66 range. The directions do say go to correct 6 decimal places. Notice, going over my white column, the bottom of the screen shows me a bunch of decimal places, so I get 6. So 0.643905. Next one down is 0.656488. Next one down is 0.661358. Followed by 0.666114. And finally 0.666611. All right, so as t is getting closer to 1, so we're going this way to get closer to 1, the results are getting closer, it looks like, to 0.67 from the right-hand side. So we start at 1.5, getting smaller, so that's a right-hand limit. If we do the left-hand limit, again, 5 numbers that aren't really, not really close, closer. So 0.5, not really close. 0.8, we're getting closer. 0.9, that's getting really close. 0.99, a lot closer. 0.999, super duper close. And go back in this column and we start entering 6-digit decimals. 0.704350. 0.678984. 0.672503. 0.667225. And finally 0.666722. Okay, so here I'm getting closer going this way, so I look at these going this way. They look to be approaching 0.667. 0.667, so 0.667. All right, and notice if I did a window here that was meaningful for these numbers from 0.5 to 1.5, I put my y's from 0.6 to 0.7 because that's about where they all are. Hit graph. Notice there's a hole at 1, but the graph itself seems to be continuous except for that. So the left-hand limit, the right-hand limit seem to be approaching some number. That number seems to be 0.667. All right, if I were to trace this along, kind of see 1 blank, right? That's right in the middle. But if I go just a little bit to the left, 0.6678, just to the right, 0.6662. That 0.667 seems to be a reasonable thing. The exact answer here is actually 2/3, which is 0.6 repeating. There are algebraic techniques to find that number. We'll be doing that in another chapter, though. So right now, this is a numerical technique. This represents a way you could not get the answer to a limit every single time. It takes time. It's a little bit more cumbersome than some of the algebraic techniques we'll learn, but sometimes the algebraic technique doesn't come immediately to you. Maybe you can't factor something, or maybe you can't simplify something down enough. So you might fall back to this method.